Yeah. We talk about this after. Give me like 15 and a half minutes. Okay. All right. Turn to your note sheet and the back page. That's the box that we live in today. We've already talked about these. Have you already learned the law of sines? How about the law of cosines? Area. You learned this top box up here. These Pythagorean identities, we know that as well. So today we kind of navigate on down. We already know some of these other things. We know conversion of degrees to radians, area of sector, arc length. So this is some good stuff. Right now we want to focus on sum and difference formulas. So here's the deal. From what we did yesterday and the day before that, so all this week, reducing trigonometric identities, simplifying them, we can make trig identities look all sorts of different ways in order to then write new formulas. So what I'm going to do today is I'm going to write a couple new formulas for you. And you might ask, where did they ever come up with that? I'm not going to actually show you where they come from. If you'd like to look in the book or come see me after class, I'd be happy to prove the formulas for you. But we just don't have enough time to do all of these. You know what I'm saying? We just don't have that time. And so therefore, I'm going to write down the formula. We could simply use the skills that we learned the past few days to derive these, but you're just going to trust these, okay? So as we look at 7.2, this page right here, do this stuff, and we'll write it down, but that back page is what we're going to really kind of pull things from. So, if you have the sine of one angle plus another angle, the question is, what does that look like as a formula? And why would you need to use it? We'll do some examples here in a second, but first just the formula. I want you to understand that you cannot take the sine of A and add it to the sine of B. This is completely incorrect. In fact, I would say that about, half a dozen people on the test will simply write sine of A plus sine of B, and I will award them absolutely no points for that because there's nothing correct about that. All right? Rather, the sine of A plus B is equal to the sine of A times the cosine of B plus the sine of B times the cosine of A. So if you want to expand that, you must write it like that. You might ask why. Again, we can prove it for you. You can look in your book. It's all there. If it was subtraction, so there's A minus B, then you would have a minus down here as well. And again, as we looked at that page, you can see it's sitting right here. Sine of A plus or minus B writes out like that. You can switch the sine and the cosine around as I did. It's not a big deal because multiplication is commutative. But you know that because you're really smart. So another formula that we have is, what about cosine? Say we have the cosine of A plus B. That's a little bit different. We write the cosine of A times the cosine of B. And then we don't do plus, we do the opposite. So we do minus the sine of A times the sine of B. So suppose instead of plus it was minus, what would I put down here? Plus. So the plus and minus switch for that one. So I know you've seen a plus minus sign before. This might be the first time you've seen a minus plus. Yes, so if you see plus here, you put minus there. If you see minus here, you put plus here. Whereas for sine, if it's plus, it's plus. If it's minus, it's minus. Okay. All right. So if it's cosine of A plus B, then there will be a minus sign down here. If it's cosine of A minus B, it will be a plus sign down. Okay. All right, let's try to retrieve some previous learning. Do you know the exact value of sine of 23 degrees? No. Do you know the exact value of sine of 30 degrees? Yes. What is it? 0.5 or 1/2. Do you know the exact value of tangent of 60 degrees? You do. It's the square root of 3. Where am I coming up with these? Okay, 30, 60, 90, 45, 45, 90. You also have the unit circle, which I gave to you with all those notes on there. So the question is that we know exact values of certain trigonometric functions and angles. We don't know the exact value of sine of 23. We don't know the exact value of cosine of 67. Yet it wants me to simplify this. Well, this looks very similar to something I wrote above, doesn't it? Looks like sine of A times the cosine of B plus the cosine of A times the sine of B. What is angle A in this scenario? 23. What is angle B in this scenario? 67. So you can see that by our formula up above, we know that this simplifies. It simplifies to the sine of something, 23, plus 67. It's the sine of A plus B. I'm sorry, I'm actually gonna write that. You don't have to write it, but sine of A plus B is what this formula simplifies to. And you said that angle A was 23 and angle B was 67. What is 23 plus 67? 90. And on the unit circle, 90 degrees has a terminal point of 0, 1. Is sine the x value or the y value? The y value, so I get 1. Your calculator will come up with an estimation, and I think it might be able to find 1. What's that? Well, cosine is x value. Yes. We'll look at one that doesn't work cosine. Say 22 plus 67, and we got no shot. Yeah, we don't. That's really good. So there's some that work out nicely. You could, but on the test, and I'll be clear, you have to show this work to get credit. So if you want to try to verify your answer, you could type in this plus that on your calculator to see, oh, I know at least what I should come up with. That would not happen. I will never give you sine of 80. Okay, B. This one looks like cosine of angle A times the cosine of angle B plus the sine of angle A times the sine of angle B. So, as I write what that formula is equal to, is this a sine or a cosine formula? This is a cosine. Cosine of A minus B, where A is 2 pi over 3 and B is 5 pi over 12. So this becomes the cosine of 2 pi over 3 minus 5 pi over 12. How do I rewrite 2 pi over 3 in terms of 12? 8 pi over 12 minus 5 pi over 12. 3 pi over 12 is cosine of pi over 4. Or the cosine of 45 degrees. What is the terminal point of a 45-degree angle? Did you say, Gabe? Close. This coordinate is the root of 2 over 2, root of 2 over 2. Remember constructing that? So therefore, cosine is the x value. The x and y value are the same. You have the root of 2 over 2. Yes. Yes. Please don't write this down, but just watch for a second. Suppose instead of choosing this to be A and this to be B, what if I switched it around and this was B and that was A? How would it have been different? It would be a cosine of negative pi over 4. Would I have still come up with this? Why? Very good. As you look right here, remember, cosine of a negative angle is the same as the cosine of that positive angle. So it doesn't matter whether you came up with a negative or a positive. You can rewrite it using your odd, even identities. Yes? Pi over 4. Yep. Okay, 2 more examples. You know the exact value of sine of 15? I look at Haley's unit circle, and it says I know the sine of 0. Sine of 0 is 0. It says I know the sine of 30. Sine of 30 is 1/2. So what's the sine of 15? I don't have a special value up there. But what I can do is I can rewrite it using a special formula. What are 2 angles that either add to 15 or subtract to 15 whose exact values I do know? Very good. We'll go 45 minus 30. Can you think of something else I could choose other than 45 and 30? What else subtracts to 15? 60 minus 45. Right. 135 minus 120. There's a whole bunch of different angles you could subtract to get to 15. Here's just 2 of them. Well, now I can expand this. This would be the sine of 45 times what? Cosine of 30. Minus or plus? Minus sine of 30 cosine of 45. I have exact values for all of these. They're on my unit circle sheet, and you know them because you know how to find terminal points of these angles. What is the sine of 45? 32 over 2. It's cosine of 30. Root of 3 over 2. Sine of 30. 1 over 2. Cosine of 45. Root of 2 over 2. Should get used to those values. I multiply. What's the root of 2 times root of 3? Root of 6 over 2 times 2 is 4. Minus the root of 2 over 4. Do those have the same denominator? So I can therefore write it as the square root of 6 minus the square root of 2 all over 4. Sometimes you're given an angle in radians. I think it's hard for people to think in radians, so you can convert it to degrees. What is 7 pi over 12 in degrees? Multiply by 180 over pi to make your conversion. You can see that the pi's cancel. 180 divided by 12 is 15. 15 times 7 is 105. We have the cosine of 105 degrees. I need two angles to either add 105 or subtract to 105. Any thoughts? $45 plus 60, correct. Or 135 minus 30. You have lots of options, okay? So I'm going to choose 60 plus 45. So 105 is the same as 60 degrees plus 45 degrees. Well, what I can do now is I can rewrite these using our formula that we have involving cosine. It says I take the cosine of what? Times the cosine of 45 plus or minus sine of 60 sine of 45. What's the cosine of 60? It's actually 1/2. Cosine of 45, root of 2 over 2. Sine of 60. Root of 3 over 2. I appreciate the guesses. Keep guessing. It's okay. Pi over 2. It sounds good. It's 90 degrees. Sine of 45. Root of 2 over 2. All right. You multiply these. I get root of 2 over 4 minus the root of 6 over 4. Do those have common denominators? Yeah. Root of 2 minus the root of 6 all over 4. Does that look similar to your last answer? You're going to get a lot of root of 2s, a lot of root of 6s, a lot of 4s. That's the way a lot of these problems are going to go. There's only so many problems we can ask to actually add or subtract a known sum, right? But what's kind of neat is that now we know 15, don't we? We know the exact value 15, so we could add that to our list and use it to find other values, okay? So I just want to show you one thing with the calculator, and then I will go ahead and give you your assignment, and that's all we have for today. If I type in, I'm going to be working in degrees, and I'm going to type in cosine of 105. So again, this is what not to do on the test. People will type in cosine of 105, and they will write down on the test negative 0.2588190.451. And they feel very confident about that because they say, that's an exact value. No, it's not. It's an approximation. It's very accurate. It's accurate to 10 decimal places, but it's an approximation. This is exact, okay? Now, if you want to check to see if your answer is right, go ahead and go parentheses square root of 2 minus square root of 6 and my parenthesis and divide that whole thing by 4. And you can see I do get that answer. So we've found the exact value. Your calculator comes up with an approximation. Very accurate one, but still an approximation. I can teach anybody to type in 105 and press cosine. It's not what I'm testing. Is that fair? Okay. All right. Oh, you need an assignment. You're good? What if we did that? No homework, just the test. So you just take the notes and then just the study guide. So why do we do homework then? Like what if we could just do the study guide and figure it out for the test? Why even do the homework? Yep, short term and long term. You got it. So, this assignment is actually short enough that you might be able to get it done in the hour. You have 24 minutes. Go. Look at that. Oh, I thought I beat the 20-minute mark. Not